Okay, let's talk a little bit more about these arithmetic sequences and what you can get out of them. So, again, referring to your textbook. So, here we're now on 558, and a term they're going to use is initial value or starting point or zeroth term. You don't often think about when you're counting starting with zero. It turns out when you're doing your math, sometimes there are times when that does make a little bit of sense. And the zeroth term is that initial starting point, which even though it often doesn't show up in a sequence, it's what you get if you imagine going one step before the first term. That's your zeroth term. So T1 is the first, and it's the first number that's actually listed, but T0 is the initial value, the starting point. So consider this sequence. All right, so first off, it's not going to be geometric because you got negative switching over to positive and then staying that way. So it looks like, if anything, it's going to be arithmetic. So this goes up by 3, by 3, by 3. Yeah, it's an arithmetic sequence with a common difference of 3. So what is the common difference? We just answered that. We're going up by 3 each time. What is the first term? Don't make that complicated. That's just the first number in the list. Now what is the zeroth term? I want to remind you of some things that we did all the way back in August or September when we had a list of ordered pairs. So if I had like the first term is -4 and the second term is -1, we ended up then imagining, what if we went backward one more spot? What would the zeroth term be? Now, we didn't call it the zeroth term at the time, but we're going to use that same procedure here. So if each time you go down, you're adding 3, well, then each time you go up, you're going to be subtracting 3. You're doing the reverse. So -1 minus 3 takes you to -4. -4 minus 3 would take you to -7. And that's how you figure out your zeroth term. It's basically your first term minus the common difference. There it is. Write an equation for t of n, and then verify that the equation works for the first 4 terms. That, by the way, is a great way to check and make sure your equation is right, is to make sure that it works for all the terms you have listed. Now, I'm going to remind you, we have 2 versions. If it's based on the first term, then it looks like this. T of n equals T1 plus the common difference times n minus 1. It looks a little clunky. There's kind of a lot going on. If we base it on the zeroth term, it just kind of looks a little nicer because it's just the zeroth term plus the common difference times the term number. You don't have this extra -1 floating around. That's one reason that we like, as mathematicians, to use this zeroth term version. It's just a little simpler. And so I think that's the version I'm going to use this time. So coming over here, my equation is going to be Tn equals my zeroth term, which we found was -7, plus the common difference, which is 3, times the term number. There you go. That's your equation. Now, if you used the based on T1 version, it's still going to give you an equivalent equation. It just doesn't look as simple. Okay, now let's verify this works for the first 4 terms of the sequence. What that means is I should be able to put a 1 in for the n and get a -4 that comes out because the first term of the sequence is -4. So let's do that. -7 plus 3 times 1. Well, 3 times 1 is 3, and -7 plus 3 is -4. That works. Let's check the second term. Now, the second term should end up being -1. Let's make sure that happens. So -7 plus 3 times 2. Notice I'm just putting the term number in where this n is, and now we're simplifying. -7, 3 times 2 is 6. Add those up. Okay, that checks out as well. Let's keep going. We're supposed to check all 4 terms. So the third term should be 2. Let's see if that happens. So -7 plus 3 times 3 for the third term now. Plus 9. Yep, that turns out to be 2. And then let's check the fourth term. Negative 7 plus 3 times 4. Do a little pause here while you check this one. Unpause when you're ready to go on. It's going to be negative 7 plus 12, which is just then 5, which is what it should be. Okay, so verify the equation works. Our equation works. So we found the 0th term. And actually, tell you what, I'm going to be a little bit more careful with my notation here. So I'm going to call this the 0th term. So T0. And I'm going to call this the first term, T1. So the 0th term, the first term, the common difference. And then down here, we've found our equation and checked our equation. Next up, is it possible for T of n to equal 42? This is a good question. And there's a couple ways to go about it. Here, I think, is the easiest. Let's imagine that it happened. So let's say that I have a term that is 42. And then let's find out what term it would be. So I just replace this T of n with the number 42. We're now going to see how things turn out. So to get this n by itself, we are going to add 7. So I've got now 49 equals 3n. And I'm realizing I didn't leave enough space, so I'm going to make some more space. Let's continue on. I still want to get n by itself, so let's do a division by 3. And see what we get. So the n we end up with, I'm just going to check here, 49 divided by 3 is 16.3 repeating. Now, here is where I would like you to stop. Do a pause. If you're working with a partner, which is great, by the way, have a discussion about whether or not we think 42 is a term in the sequence. And then unpause when you're ready to move on. Okay, here's the thing. Remember that in our sequence, our n's are counting which term we're in. So you can have a 2 or a 7 or a 12. You can't have a 16.3 repeating. There could be a 16th term and a 17th term, but there won't be a decimal number of terms. So if 42 were in the sequence, then you would have a whole number here as your result. So is it possible for T of n to equal 42? No. Why not? Because we would need a decimal number of terms, which just doesn't make sense since we're counting whole numbers. Now our equation here was negative 7 plus 3n. I need you to see how that's similar to this equation. So let's just do some writing. So our T of n was negative 7 plus 3n. If you just change the order here and make it 3n minus 7, that's the exact same thing. And I hope you can see then how that matches up with this. T of n becomes f of x, 3n is 3x, and the minus 7 is minus 7. Now the follow-up question here is, all right, if you have this equation, so separate from our sequence, if you just have this equation, is it possible for f of x to equal 42? Let's not reinvent the wheel. We would be solving this equation, 42 equals 3x minus 7. That's the same equation we already solved up here. And the answer we got was 16.3 repeating. So is that possible? Yes. This is okay. So up here there was a problem. Down here it's all good. What's the difference? It has to do with that discrete continuous difference that we talked about in the previous discussion. If I graph f of x equals 3x minus 7, you get a solid line. Whereas if you were to graph our sequence, it's going to be separate points. So that solution, the line 42, it is a point on the continuous graph because it falls at a decimal x value. But on the graph that would be just dots, the sequence graph, it would fall between the dots. which isn't super helpful for us. So especially for those of you that are going to be taking integrated 2, this is important to know. A continuous linear equation is going to have a solution. The discrete version, where your points are separated and only on whole numbers, sometimes doesn't have a solution, and that's the way you can check. So what's the difference? Well, we already had that discussion. That's what we just did. The difference is that T of n is discrete, meaning the points are separate, whereas f of x is continuous, where you have a solid line. So when we put in, let's say an output of 42, so that would be something at, say, this height. Well, here, things line up. There's an intersection. But here, that exact same line at a height of 42 goes between two of our points and doesn't hit them exactly. That's what makes the difference.